The periodic table is actually an excellent cheat sheet for a chemistry teacher or student. When you look at this periodic table right now, it may not look like anything except a bunch of letters and numbers. But when I look at it, I see something more like this. Embedded in each of the sets of information are tools that we can use to compare one element to another or isotopes of atoms to each other. Now, this paper is what you will create in class. We're going to use colored markers, colored pencils or markers to do the colors, and you will have yours labeled just like you see mine is here, but I want to show you how we get to this finished product. You're going to start with a blank sheet of paper, and the main objective is for you to recognize some of the frameworks of the periodic table. Over here we have our periods. There are 7 rows on the periodic table, and each of those are assigned a number. Those numbers are called periods. So everybody on this row is in period 3. Everybody in this row is in period 6. Now, on your actual periodic table, you're going to have 2 little segments of lines down at the bottom. They are not an 8th and 9th row. They're actually an insert that belong back up here in 6 and 7, and we'll talk more about that in class. Now, across the top, you see numbers going across there as well. Those are our groups. Each column is a group. So everybody in this first column belongs to group 1. And all the way at the other end, we have group 18, and everybody in group 18 is in that same column. Now, notice that I have a B and an AT marked there. That's boron and astatine. And I have bolded the steps, if you will, on those different blocks. That is called the metalloid staircase. If you will remember to find boron and astatine, then you can remember the phrase, look for the bat on the staircase. And that staircase is your metalloids. Now, all of the metalloids are colored in yellow here, and notice that the only one that's next to the staircase not yellow is this one with the X in it. That's aluminum. Aluminum is a metal. It is not a metalloid. So it is the only one on the staircase that is not a metalloid. Everything to the right of the metalloid staircase is a nonmetal. Everything to the left of the metalloid staircase is a metal. Notice, however, that hydrogen has an X in it and is colored blue. That's because hydrogen is an exception. It is not a metal, it is a nonmetal. Okay, so all of our nonmetals are to the right, all the metals are to the left, and our metalloid staircase is on the center area. The bat is on the staircase. Now, once we have that identified, then we can start layering some of that other information on here. When you look at this, hopefully you notice that I have some numbers circled. That's our number of valence electrons. Everybody in group 1 has 1 valence electron. Everybody in group 2 has 2, and so on and so forth. When I get to this last group, 18, group 18 does not have 8 valence electrons. It has a full outer shell of electrons. Helium, however, is only full with 2. Everybody else will have 8. Now, if you notice, I said that group 18 had 8 valence electrons. The way we get that is we have to remember to subtract these 10 groups that are the transition metals from our group number. When I cross over, I have to subtract the 10 in order to get the valence charge. We're not going to worry about what the valence charge is for our transition metals. We're only going to focus on the tall groups. So from group 1 and 2, we skip over to group 13 to group 18. We also have the names of our families in here. Every group has a special name. So we have alkali metal, alkaline earth metals. The transition metals are the collective group of the short columns. Now the next 4 groups are named after the element that is at the top of their list. So this, group 13, is the boron family, carbon, nitrogen, and oxygen family. Now when I come over here, group 17 is called the halogens. And group 18 is called the noble gases. Okay? Notice that at the bottom here in group 7 we have some X's because these are not elements that we know yet. And we'll talk more about the discovery of elements in class.